Okay, so what we're going to be working on is multiplying algebraic fractions. So I'd like you to put me on pause and try this and then come back and check your answers. Okay, so we have here number 1 and 2 says to simplify. So this is what we worked on just recently. So what I want to do is I want to factor the numerators and factor the denominators and see what factors I can reduce with. Okay, so number 1, in the numerator, we have 5a squared minus 45. So I noticed there is a GCF, so I'm going to factor out the GCF, which is 5. So it's 5 times a squared minus 9. And then I noticed that I can factor again. A squared minus 9 is the difference of two perfect squares. So that's 5 times a plus 3 times a minus 3. And in the denominator, I see here that there's a GCF, and the GCF is 5. So I factor out the 5 and I have 5 times 3 plus a. So now remember, when you reduce, you could reduce any numerator factor with a denominator factor. So remember, there's multiplication in between the 5 in the parentheses and the 2 parentheses here, and the 5 and the parentheses here. So work from left to right in the numerator. So 5 and 5 reduce to 1 and 1. I have a plus 3 and 3 plus a. These two are not opposites. They are actually the same. So remember, addition is commutative. So then the only thing I'm left with left in the numerator is a minus 3. So that's my answer. Okay, so let's take a look at number 2. Okay, so number 2 in the numerator, I notice there is a GCF, and the GCF is y, so I'm going to factor out the y. So I have y times 2 minus y over, now I have a trinomial in the denominator, so I'm going to use master product. So I multiply first times last, I get negative 2y squared. So what multiplies to 2 minuses to a 1, there's really a 1 in there. That would be 2 and 1. So I have 2y and 1y. They get different signs, and I want to end up getting negative 1 when I combine, so it's negative 2, positive 1. Bring down the end, which is negative 2, and the front, which is y squared. And now I will factor by grouping. All right, so the GCF of the first group is y times y minus 2. The GCF of the second group is positive 1 times y minus 2. So then my factors are y plus 1 and y minus 2. Okay, so let's put that down. So y plus 1, y minus 2. So where are my multiplications? In between. So y and 2 minus y are factors. And my factors in the denominator are y plus 1 and then the times y minus 2. So what reduces? So I'm looking at the y here. All right, so I'm looking at y. There's no y, single y, or a y squared, or a y to the third in the denominator, so I can't do anything with this. And then I notice I have a 2 minus y. I don't see a 2 minus y, but I see y minus 2. These are opposites, right? I have positive 2, negative y, positive y. These are opposites, so they will actually reduce to negative 1. So remember, the negative 1 either goes in the numerator or denominator, not both. So then what am I left with in the numerator? I have negative y, that's y times negative 1, over y plus 1. And at this point, what you should be doing is how you write this. You really should be putting that negative right with the bar. So it's just a negative fraction, so that we're not necessarily making the numerator positive or the denominator positive. So just put the negative with the bar. All right, so now let's talk about multiplying algebraic fractions, and what do we have to do? So this is it's very, extremely similar to reducing. It's basically the same exact thing. So let's take a look at the steps here. So number 1 says to factor the numerator and the denominator completely. If you have a binomial that cannot be factored, put parentheses around it. You can reduce the numerator with the denominator. So remember, we're looking for the factors to reduce. Remember, you must have a multiplication in between those factors to reduce. When you reduce, work in the numerator from left to right. If you skip around, you might miss something. So just work from left to right. When you're done reducing, just multiply across. Multiply the numerators, multiply the denominators. So let's take a look at number 1. So number one here, I have 3xy plus 3y over 6x times 2x squared minus 6x over x squared minus 9. So I notice here in the numerator there is a GCF, and that GCF is y. So I factor out the y. So it's y times 3y. Sorry, the GCF is not just y, it's actually 3y. So the GCF is 3y here. So 3y times x plus 1. In the denominator, I have 6x. That's a monomial. You can't factor a monomial. It's already factored. It's 6 times x, so we would just leave it like that. Times, now let's work on the other side here, the second fraction. All right, so in the numerator, I have 2x squared minus 6x, so there is a GCF. The GCF is 2x, so we'll factor out the 2x. So it's 2x times x minus 3 over, and then in the denominator, I notice I have x squared minus 9, and that can be factored. That's the difference of two perfect squares. So that becomes x plus 3 and x minus 3. All right, let's just look to see where there's the multiplication here. Let's put that in. So there's multiplication in between the 3 and the y and the x plus 1, in between 6 and x, in between 2 and x times x minus 3, and x plus 3, x minus 3. Now we're going to reduce. I'm going to work from left to right in the numerator. So I'm starting with the 3. I notice that 3 can reduce with 6 in the denominator. 3 goes into 3 once and into 6 twice. And then I have a y. Y does not reduce with anything. So then I go to the next thing, x plus 1. Looking in the denominator, nothing down here to reduce it with. Now I go to 2. 2 reduces with 2, so they both reduce to 1 and 1. And then I have x. X reduces to 1 and x reduces to 1. X minus 3 and x minus 3, they reduce to 1 and 1. All right, so now that we're done reducing, and notice I worked from left to right, I didn't skip around. I just multiply across. So let's see what's left in the numerator. I have 1 times y times x plus 1 times 1 times 1 times 1. That's y times x plus 1. And in the denominator, 1 times x plus 3 times 1 is just x plus 3. All right, so let's flip it over and take a look at the back. All right, so number 2, in the numerator here, I have a trinomial, so I have to factor that trinomial by using master product. All right, so I multiply the first times the last, and I get positive 27x squared. So what multiplies to 27 adds to 12, that's 9 and 3. They will get the same signs, they'll both be negative. That'll give me my negative 12x and positive 27. And then I have positive 27 at the end and x squared at the front, and then I factor by grouping. So it's x times x minus 9, negative 3 times x minus 9. So my factors are x minus 3 times x minus 9. Okay, so let's write that down. All right, so I have x minus 3, x minus 9. All right, in the denominator, I see I have x squared minus 81. That's the difference of two perfect squares. So that's x minus 9, x plus 9. All right, and now I have times. Now let's go to our second fraction. I have x plus 9 cannot be factored, so I'm going to put parentheses around it. 3 minus x cannot be factored, so I'm going to put parentheses around that. So I have x plus 9 and 3 minus x. All right, so I have multiplication in between these two factors, in between these factors here. So now let's start reducing. So I have x minus 3. I'm looking for another x minus 3. I don't see an x minus 3, but I see 3 minus x. They are opposites, so they reduce to negative 1. X minus 9 and x minus 9, they reduce to 1 and 1. X plus 9 and x plus 9 reduce to 1 and 1. So my answer, what's left in the numerator, is just negative 1. All right, so let's take a look at number 3. All right, so I'm going to start factoring. So 2x minus 12, there's a GCF. The GCF is 2 times x minus 6. In the denominator, 3x minus 6, there is a GCF, and that GCF is 3, and then I get x minus 2. And then I have times. X squared minus 4 is the difference of two perfect squares, so that's x plus 2 and x minus 2. In the denominator, x squared minus 36, there's a GCF, that's the difference of two perfect squares. That's x plus 6 and x minus 6. And then 3x plus 18, the GCF is 3, and then that's times x plus 6. And in the denominator, the GCF of 4x plus 8 is 4, and that's x plus 2. And let's see where my factors are. I have multiplication in between 2 and x minus 6, in between 3 and x minus 2, in between x plus 2, x minus 2, in between x plus 6, x minus 6, in between 3 and x plus 6, and in between 4 and x plus 2. All right, so now we're going to reduce. Remember, start in the numerator, work from left to right. So I have a 2 here. 2 and 4 reduce to 1 and 2. X minus 6 reduces with x minus 6. That reduces to 1 and 1. X plus 2 and x plus 2 reduce to 1 and 1. X minus 2 and x minus 2 reduce to 1 and 1. 3 and 3 reduce to 1 and 1. And x plus 6 and x plus 6 reduce to 1 and 1. So in the numerator, you get 1 over 2 in the denominator.